To start this review, we're going to look at solving quadratic equations and some parabolas. So the first question asks us to solve. So it is a quadratic with a leading coefficient of 2. It's equal to 0. So I'm going to see if I can factor this first. And I'm not going to spend too much time trying to factor this. But I'm checking to see if it's easily factorable. And it looks like that there's no two numbers that would multiply to 10 and add to 5. Okay, so this is not factorable. So I'm just going to go right ahead and skip straight to the quadratic formula. So x is equal to negative of negative 8, so positive 8 plus minus square root negative 8 squared minus 4 times a times c. So there's the top, and then the denominator is going to be 2 times 2. So just checking the signs, I need to make sure I subtract that. So x is equal to 8 plus minus square root 64, and that's going to be equal to 40 over 4. X is equal to plus minus square root 24 over 4. Now that's the answer, but we can simplify this because there is a common factor of 2. We have to factor that 2 out of the root 24. So we end up with x is equal to 8 plus minus the square root 24 is going to factor into, well, we're going to factor 4 times 6, so that 4 comes out of the square root, and we're left with 6 inside. And that's all over 4. So we can simplify this fraction because all those terms share a common factor of 2. So I'm going to divide the top and bottom by 2. For number 2, it says find the equation of the parabola that has points at 3, 9, 7, 9, 5, 0. Now, it's important to recognize, you may not recognize it, but if we take a look at those 2 points, they are the same y-coordinate, so that means they're symmetrical. The other coordinate is a y-intercept. So it's a good idea to just sketch a quick little picture, just to see what this looks like. I have y-intercept at 5. I've got a coordinate at 3, 9. Oh, sorry, that's not a y-intercept, that's a 0. So at 5, 0. Okay, at 3, 9, maybe somewhere around here. And 7, 9, somewhere around here. And because that point is in the middle, okay, so if you recognize that it's right through the middle here, okay, recolor that. Okay, it's going to be right through the middle. That must be the vertex. Okay, so we can do this many different ways. So if we recognize it's a vertex, we can just start with this equation and just say that this is y equals a x minus 5 squared plus 0, and solve for a by substituting in an x and y coordinate. So I'm going to substitute y is 9, x is 3, and we get, that's going to be 4a equals 9, so a is equal to 9 over 4. So that would be one way to do it. So I get y is equal to 9 over 4, x minus 5 squared plus 0. Okay, so there's one solution using the graphing form. We could have tried doing this as a system of equations, and so this is an alternate solution. I could use the 0 form, so a x minus 5, x minus m, and then we have 2 variables to solve for, and we have 2 coordinates that we can use. So I can use the coordinate of 9 and 3. And that generates this equation. I'm going to simplify that. Okay, so that's one equation, and I can then use the other coordinate of 7, 9, and I can do the same thing. So I end up with 9 is equal to negative, that's going to be, oops, just going to plug that in, a times 7 minus 5 and 7 minus m. That simplifies to 9 is equal to 2a 7 minus m. Okay, and then we can use a system of equations there, and we can solve that as a system of equations. Okay, so this is by far the harder strategy. So if we can recognize the symmetry and the fact that that green coordinate is the vertex, that will help out greatly. So example 3 says, explain the axis symmetry, how it shows up in the quadratic formula. So what I've highlighted here is this part of the quadratic formula, and that is Vieta's formula. And Vieta's formula shows up in the quadratic equation, and that is the middle of the graph. And really we can justify this being the middle of the graph because if we think about how this quadratic formula works, it's going to be b plus minus. That means that b over 2a must be the middle because we get the roots by going plus with the discriminant, the square root of b squared minus 4ac, and we also do minus square root of b squared minus 4ac. And that gives us plus minus from the middle, which is that negative b over 2a. And so that justifies our axis of symmetry. We can then kind of sketch this out. We have our graph here. We're just going to draw some arbitrary graph. And we have some parabola here. That b over 2a is going to show up in the middle. Okay, that's going to be our negative b over 2a through the middle. And then we're going to have to the 0 here plus square root of b squared minus 4ac over 2a. And in this direction to the other root, we're going to have minus the square root of b squared minus 4ac over 2a. And that's going to give us the two roots, and that means that that b minus b negative b over 2a must be the middle point, which is also where we're going to find our vertex.